Hello everyone and welcome back to my channel. If you're applying for a DevOps SRE or dedicated Kubernetes administrator role, you know that the interview won't stop at what is a pod. Hiring managers want to test your production readiness, your ability to troubleshoot a cluster during a critical outage, secure API access, and manage stateful applications at scale. Welcome to this session where I'll be covering 15 essential scenario-based questions designed to prove you can manage and maintain a robust Kubernetes cluster. This is where we separate the users from the administrators. If you can nail these answers, you're ready for any large-scale cloud environment. Now, before we start with the questions, I have one simple request. Please hit that subscribe button. It really helps the channel grow. Now, let's get started with the first question. So you have a cluster with dedicated database nodes. A new deployment for a front-end application fails to schedule on any node. What is the most likely cause and how do you fix it without changing the node label? So the database nodes might likely have a taint applied, which can be preventing the scheduling of non-critical workloads. So for this, you can apply an appropriate toleration to the front-end pod specification, which is basically your deployment YAML specification file. And the toleration must match the key value pair that you have within your YAML file and the effect of the taint on the node that you have applied. So basically, the taint that you have applied on the node and the toleration that you have defined in the YAML file should match, and then your workloads will start deploying on your database nodes. The next question we have is you have two microservices, payments and inventory, running in the same cluster but different namespaces. You must ensure inventory can only receive traffic from payments. How do you enforce this network isolation? So for this, we can make use of your network policy object. So you can create a network policy in the inventory namespace that specifies an ingress rule. The from selector must target the pods that are running in the payments namespace. This will limit the traffic to the defined source. So basically create a network policy, define your ingress rule, and then your from selector must be the pods that are running the payment namespace. The next question we have is a node transitions to a not ready status and the logs shows the condition kubelet has disk pressure. What two commands or steps would you use to confirm and mitigate this immediately? So one command that you can use is you can use this kubectl describe node and the node name and then check the condition section for the specific usage percentage like your image fs or root fs. Then you can use this kubectl garbage collect feature or manually delete any unused images or any containers on the node via this CRI CTL utility. So basically check if there are any conditions or what's the percentage of your usage that has happened, and then see if you can delete any unused containers or any unused images that can help you free up some space. The next question we have is you need to expose a production API service to the public internet using a cloud provider's managed load balancer. What's the preferred Kubernetes resource for this and why is node port usually discouraged? So for this, we can make use of your ingress, usually your ingress controller or like Nginx or Traffic or a service of type load balancer. If you're on AWS, then you can make use of your application load balancer. The node port is generally discouraged because it exposes the service on every node's IP address, typically in a high port range. Now, this is very difficult to manage the firewall rules, and this relies on external manual load balancing, making it very unsuitable for production external access. So that's where it is recommended to make use of your service type load balancer and not your node port if you're exposing your containers on the public internet. The next question we have is a newly deployed pod repeatedly goes into an image pull back off state. List the top 3 potential causes you would check immediately. So the first thing we can do is we can verify the image name and then the tag of the image in the pod specification, whether they are correct and they exist in the registry. So you can run this kubectl describe pod command. Then you can check if the node has connectivity to the container registry, like your node is able to talk to your Docker Hub or your ECR, the registry that you are using. Then if it's a private registry, ensure the pod specification correctly references a valid image pool secrets object. So basically check whether the image is there or not, whether the node has the necessary connectivity, or there are some necessary permissions that are defined. That way you can troubleshoot why you are getting that error. The next question we have is, a new junior administrator needs the ability to view all resources cluster-wide, but should absolutely not be able to create, modify, or delete anything. What two RBAC resources do you create to grant this specific read-only access? So we can create a cluster role with verbs like get, list, watch for all desired resources. So basically you can use a wildcard. Then you will do a cluster role binding to attach that cluster role to that specific user or to that specific service account. So that way you're only giving the necessary permissions, but cluster wide level. The next question we have is, when deploying a database like PostgreSQL, why must you use a stateful state instead of a standard deployment? So stateful state provides stable, unique network identities like your host names, and this guarantees a consistent volume naming or mapping across your pod restarts. Now, this is very essential for databases where data persistence and network identity must remain stable regardless of pod failures or scaling events. So deployments that does not provide that, that's where we make use of your stateful set. So whenever you need that consistency with your volume naming or mapping, even if there is a pod restart, then we can make use of your stateful sets. The next question we have is, your application pod enters a crash loop because its liveness probe keeps failing. What's the key difference between a liveness probe failure and a readiness probe failure in terms of Kubernetes actions? So the liveness probe failures is basically where the Kubernetes assumes that the application is unhealthy and it cannot recover. The kubelets action is to simply restart the container. So every time it sees that the application is unhealthy, it tries to keep on restarting the container. The readiness probe failure basically indicates that the application is temporarily busy, and the kubelets action in this case is to remove that pod from the services endpoint list, stopping any new traffic. All right, so liveness probe, the kubelet will keep on restarting the container. Readiness probe, kubelet will remove that pod so that it won't receive any new traffic. The next question we have is, you need to perform a major version upgrade of your cluster from, let's say, version 1.28 to version 1.29 using kubeadm. What is the single most critical step you must perform before starting the upgrade on the control plane node? So for this, the first thing that we need to do is back up your etcd database, because this is where all of your sensitive information, your cluster related information is stored. So this etcd holds your entire cluster state. And if the upgrade fails for any reason, then you can simply restore the etcd snapshot, and that's the only reliable way to recover the control plane in case something goes wrong. So always take a backup of your etcd before you start your upgrade process. The next question we have is, a developer complains that their pods are being evicted by kubelet. The eviction message mentions OOM killed. What cluster resource object should you implement to enforce resource ceilings and prevent this in their namespace? So for this, you can implement a limit range resource. So a limit range resource can be used when you want to enforce default resource limits and requests on pods within a particular namespace. So setting these limits will prevent a pod from consuming excessive resources and getting OOM killed or evicted messages. So basically, you put limitations on how much of resources your pods can consume. That way, you can avoid this particular error. The next question we have is, storing database credentials directly in a native Kubernetes secret is considered insecure. Name two popular third-party solutions used in DevOps environments to manage and inject secrets more securely. So the first option we have is HashiCorp Vault. So we can use this for centralized managed secrets storage and dynamic secret generation. The other option you have is sealed secrets. This will help you to encrypt the secret YAML file, and that will allow it to be safely stored in Git, which can be used within your GitOps workflow. And that way only the controller in the cluster can decrypt the secrets, and no one else will be able to decrypt that particular secret. The next question we have is, what is the primary function of CNI, Container Network Interface plugin, in a Kubernetes cluster? So the CNI plugin is responsible for pod-to-pod networking. It mainly allocates IP addresses to pods and implements the network overlay. And this allows the pods on different nodes to communicate directly with each other. So basically, your CNI plugin is the networking component, and it is responsible for your pod-to-pod communication. So it basically think of it as a single network where all of your pods are implemented, and that allows your pods to talk to each other. The next question we have is, your application update is failing due to a bad image and the deployment is halfway through its rolling update strategy. How do you immediately stop the rollout and revert it to the previous working version? So for this, the first thing we need to do is stop the rollout. So you can use this kubectl rollout pause and your deployment name to stop the rollout immediately, and then you do a rollback. So you can use kubectl rollout undo and your deployment name to revert your application to the previous successful revision immediately. So stop the rollout and then revert it to the previous version, the stable version where your application was working. The next question we have is, you need to run a log collection agent like Fluentd on every single node in your cluster, including new nodes added in the future. Which controller should you use and why? So for this, we can use the daemon set controller for this. So a daemon set ensures that a copy of the specified pod is running on all or all the specified nodes. Now this will automatically schedule the pods onto new nodes as they are added to the cluster. So make use of a daemon set, and the daemon set will ensure that one pod is running on all the nodes, and even when you add new nodes, the daemon set will ensure that the pod is automatically deployed on these new nodes whenever they are added to the cluster. The next question we have is, your 3-node etcd cluster loses 2 members simultaneously. What is the immediate impact on the Kubernetes control plane and what is the required quorum? So the control plane becomes read-only and non-functional. So if 2 control plane goes down, then the third control plane will become read-only. You won't be able to add any new information to it. No new changes like creation, updates, or scalings can be accepted, although any existing workloads will continue to run because it's read-only. So whatever you have in the cluster, that will continue to run. So for an odd number of nodes, like in this case 3, the required quorum is n by 2 plus 1. So basically you need a minimum of 2 control planes to be running. So basically for a 3-node cluster, the quorum is 2. So losing 2 nodes means the cluster falls below the quorum, and that's why the last control plane becomes read-only and non-functional. So basically we need to ensure that at any point we have 2 control planes running for your cluster to work as expected. And that brings us to the end of the session. I have covered everything ranging from cluster security with RBAC, critical storage scenarios with stateful sets, advanced troubleshooting with Taints and Tolerations, and the essential recovery step of backing up etcd. If you were able to clearly articulate the difference between liveness and readiness probes, and you know why network policy is crucial for isolation, you are ready for a top tier DevOps or SRE role. If you found this session helpful, please hit that subscribe button, like, share, and provide your feedback in the comments section below. Thank you for watching, and I will see you in the next session.